Greetings, YouTubers out there in YouTube land. It's been quite a while, but I felt compelled to make this video. I feel like I'm starting to get this whole scientific method thing figured out, so I wanted to make this. And the person who gets the most credit for these ideas, I'll put a link to them below. I'm not sure they'd really agree with everything I'm saying here, but this all seems to make sense to me, at least so far. And what I'm really starting to think is that the same method that is used for economics is the same method that is used for the physical sciences. The only reason that there is this idea that there's different, that they're sort of like soft science or hard science, that they're different in some ways, because scientists have been incorrectly going about the scientific method, at least as far as physics goes. So what I'm going to argue here, I'm not really going to argue, well, I guess I will argue some things, but more or less just want to present it. And I'm not going to make the further argument that this is the scientific method and then that nothing else is the scientific method. I just want to at least present this and try to get these ideas across because I think it clears up a lot of confusion. So for the sake of clarity, I'm just going to call what I'm talking about the explanatory scientific method as versus the common scientific method, just to clarify. Anyway, so first and foremost, in terms of just major differences between the two, I don't think the explanatory scientific method doesn't have anything to do with doing experiments. It doesn't have anything to do with trying to assess the truth or falsity of a theory, which is what people commonly think of when they think of the scientific method. It's about, we got to do these experiments, and we're trying to figure out whether or not this theory is true or not, and that's the point of science, to determine what the correct model is or what the most correct model is. And I don't think that is at all the case. And I think at the very least, people out there would agree with me that the very first test of any theory should not be an experiment. It should be, are the definitions of your theory being used consistently? Because if your definitions are not being used consistently, then what's the point of even attempting to assess whether or not the theory is true or false or whatever? If your theory isn't internally valid, there's no point in doing any kind of empirical experiment on it, any kind of empirical test whatsoever. And then I'd take that a step further and say the second, or the first or second, doesn't matter, a test of any theory also is not empirical, and that would be the question of whether or not it's rational. So it's pertinent at this point to define the term rational. I don't really see anybody doing that. It's used pretty vaguely, so I think in a scientific dissertation you have to define the term clearly, and I think there's a simple definition for that term, which is just conceivable. So I'll just say conceivable or rational. They're the same thing. And also I think it's pertinent to define the term knowledge at this point, and I would reject Plato's definition, justified true belief. That might be the subject for another video, but suffice to say, I think the only definition that could be used consistently for knowledge is it being synonymous with experience. To know is to experience. So we experience the models that we formulate, i.e. we know, we have knowledge of the models that we formulate, but we don't have knowledge of their truth or falsity, because otherwise there'd be no point in attempting to formulate the model in the first place. So really what the explanatory scientific method is just a list of criteria that the theorist logically must give to whoever they're presenting the theory to in order to have what they can call an explanation. So the entire theory should be able to be presented without ever having to assess whether or not it's true or false, or ever having to do any experiments. I should be able to communicate to you the theory without having to do any of that. Then you are able to, the individual is able to assess whether or not what I have presented to you is A, rational, i.e. conceivable, and B, whether or not the definitions that I'm using are being used consistently. So I think this is what the difference is between a priori and a posteriori. You can use these terms consistently. If it doesn't make sense, if knowledge is going to be defined as experience, then it wouldn't make sense to say a priori knowledge is that which is before experience, right? So I think what a priori really means is before you assess the truth or falsity of a theory, whereas a posteriori is when you attempt to use empirical means to assess the truth or falsity of a certain theory. So the first stage of the explanatory scientific method would be the hypothesis stage, And there are 3 criteria within that stage that the theorist must give in order to formulate an explanation later on. And I think first and foremost, I would argue that that would be the causal agents of your theory. And this is probably like the most key aspect of this whole thing. You have to tell me what the causal agents are that exist beyond your direct experience, right? You have experience, i.e. knowledge of the model that you formulate. And that model is supposed to represent something beyond your direct experience, which you are hypothesizing to exist. And you must hypothesize the existence of certain causal agents in order to have an explanation, because otherwise, what would your explanation be? If you aren't telling me what the things are that are doing the stuff out in the world, then where is your explanation? There's got to be something out there doing stuff that explains then later on our observations. So that's also why I'd say that the only place knowledge has in science is the knowledge of the models that we formulate, but we can never have knowledge of the truth or falsity of those models because we don't directly experience what we're hypothesizing to exist. So to give some examples, causal agents in physics, I would agree. I think the best definition, i.e. the definition that can be used consistently for your causal agent in physics, would be 3-dimensional shape, 3-dimensional form, whichever one you want to use. Same thing. Shape, form, those are the physical objects that are out there that are doing the stuff. That's how we formulate the explanation. In economics, that would be the existence of external minds. Both of these are conceivable. So that would be the first test. Okay, is it conceivable? Yes, I can conceive of the whole range of 3-dimensional shapes. Yes, I can conceive of the existence of external minds because I myself have a mind. And again, at this point, I'm not assessing whether or not there really are these shapes out there or whether or not there really are external minds. That's irrelevant at this point. The first question is it even conceivable? Because if it isn't even conceivable to my mind, it's irrelevant whether this thing really does or doesn't exist. If I can't conceive of it existing, then there is no model, then there is no theory, then there is no explanation. And so that's why all of these theories of physics fail. They fail at the hypothesis stage because they invoke the incomprehensible. They invoke the inconceivable, like bending of space or 0-dimensional particle or higher dimensional objects or 1-dimensional strings. Nobody can conceive of these things actually existing being the key word there, regardless of how much mathematical training they've had. I mean, what is math? It's just a bunch of symbols. The mind must understand those symbols and then create an image. And the human mind just simply is not capable of conceiving of the existence of higher or lower dimensional objects or bending of space, of any of these things. So again, what I have knowledge of is the model. So I know whether or not the model is conceivable. That's what I know. I don't know what is or is not possible out in the universe. And the argument I usually get back on that was, well, just because your tiny primate brain can't conceive of it doesn't mean it doesn't exist. Well, yeah, sure, but if you're saying something exists, I should be able to conceive of it. Otherwise, you can't even tell me what exists out there. That's the problem, not whether or not it really can exist. It's whether or not you can define it. Okay, so the second thing you'd be required to give in the hypothesis stage would be your static definitions. And I say static definitions because the hypothesis stage really is sort of like a freeze frame image. You're telling me what exists out there, you're giving me your definitions, and lastly, your initial conditions. So your definitions, physics, that might be, like I said, shape. It might be length, distance, those sort of things. As far as economics goes, that might be, choice or a certain felt uneasiness or something like that. And then your initial conditions would just be basically painting the initial scene of the theory. So for physics, that might be like, okay, what exists are these particles, these particle things, and your initial condition would be, exactly how they relate to one another, and basically the initial scene of your theory. Whereas economics, that might be a given supply and demand schedule or a value scale or something like that. So once you've given all that, you can move into the theory stage. And here's something interesting to point out is when you're talking about the common scientific method, you're forced to introduce these standards of empiricism based upon consensus. What's acceptable and in terms of trying to determine the truth or falsity of a theory. With this, you don't have to do that. You don't have to depend upon the authority of scientists. You don't have to depend upon consensus. The individual is sort of returns science back to the individual. The individual is in the position to determine, only the individual is in a position to determine whether or not a theory is conceivable and whether or not the definitions are being used consistently. So when I say you've entered the theory stage, in the common conception, when something becomes goes from a hypothesis to a theory, that all depends on how many scientists agree with that. Whereas in this conception, the explanatory scientific method, when you enter the theory stage, isn't a matter. You don't need to look up in a book or ask a scientist when something becomes a theory. You enter the theory stage when the concept of causation enters the picture. If the hypothesis is a freeze frame, then your theory is like a movie. So very simple, okay? Causation enters the picture. Causation is something that's universally recognizable to human beings. So there, you've entered the theory stage once you bring causation in the picture. And there's another three things that you must give within the theory stage. So the first thing you would give in the theory stage would be your rules of cause and effect. So for physics, that might be you tell me what happens when those little particles, maybe what happens when they collide. Do they pass through one another? Because that's conceivable. Do they melt together? That's conceivable. Do they push off one another and bounce off? So if they bounce off every time, then if I'm establishing that as a rule, then I'd have to stay consistent with that rule from then on as I give my explanation. And in economics, that would be basically the subjective theory of value. It would be the cause is a felt uneasiness, and the effect would be the attempt to move into what the individual subjectively perceives as an improved state of affairs. And then the next thing you'd give are your dynamic definitions, which in physics that might be something like energy. Okay, energy is the motion of these particles. Done. And in economics, that might be various definitions like psychological profit, psychological revenue, psychological cost, etc., etc., etc. And then the last thing you give is the explanation, which can then be deduced from everything that you've given thus far. So if you stay consistent with your rules in physics, that your cause and effect rules and all the causal agents you've hypothesized and your initial conditions and your definitions, then you can deduce all these various explanations. Same thing in economics, you can deduce all the other explanations from the subjective theory of value. And once you've got all that, you're done with the theory stage and you can move into the conclusion stage. What separates the conclusion stage from the theory stage? Something that's got to be universally recognizable, which is that now you can bring in this whole idea of questioning whether or not a theory is true or false, or how strongly it corresponds with what is really, quote unquote, out there. And that's then in the conclusion stage when you could bring in all your experiments and data and observations, and your conclusion could be, okay, I've given you my explanation, which I've deduced, and now here are all these observations I made, here's all these experiments I did, and these are the explanations for what we're seeing and for why these experiments turn out the way they do. This way you can be absolutely positive that you're being consistent in all the various explanations that you give for your various experiments. So now it makes a lot more sense out of everything, and all these terms can be used consistently, like terms like rational, knowledge, hypothesis, theory. Hypotheses never become theories. They're just different stages of the scientific method, and when you enter the theory stage, that's, again, universally recognizable. Causation. You don't need to ask a scientist. You don't need to ask a scientist whether or not a theory is rational. You don't need to ask a scientist whether or not the definitions are being used consistently. You can see that for yourself. So now we don't have to have faith in the authority of scientists, because we now have a bulwark against corruption and self-deception in science, which is the first two tests of any theory, being rationality and are the definitions being used consistently. And once again, in the explanatory scientific method, at no point before the conclusion stage is the truth or falsity of the theory assessed. It's all just taken right at face value for the purpose of understanding the theory. And then, of course, at the conclusion stage, whether or not you accept a theory is a matter of your scientific opinion. They cannot be proven or disproven because we cannot have knowledge of their truth or falsity. So I think Austrians should really take a look at this, because as far as I can tell, the Austrian School of Economics is the only one that follows the explanatory scientific method, and now Paul Krugman can't go around so easily saying, hey, you're being unscientific. All right, that's all I got. Peace.